Our objective in this lesson is to simplify radicals by reducing the index. Let's have a review first. Fourth root of b to the fifth can be expressed as fourth root of b to the fourth times b. And this can be further expressed as fourth root of b to the fourth times fourth root of b. Now, fourth root of b to the fourth root and 4 here can be cancelled out. So this will be b times fourth root of b. Let's have another one. Cube root of a to the 7. This can be expressed as cube root of a to the 6 times a. And can be further expressed as cube root of a to the 6 times cube root of a. Now, 6 divided by 3 is 2. So we have a squared cube root of a. Another one. Fourth root of c to the 15 can be expressed as fourth root of c to the 12 times c cubed, which can be further expressed as fourth root of c to the 12 times fourth root of c cubed. Now, 12 divided by 4 is 3. So we have c cubed, fourth root of c cubed. Now, fourth root of b to the fifth is the same as b raised to 5 over 4. So this means this is also equal to b fourth root of b. And fourth root of b can be expressed in exponential form as b raised to 1/4. So this is b times b raised to 1/4. This one is equivalent to a raised to 7 over 3. So this is also equal to a squared cube root of a. And when I convert cube root of a into exponential form, this is a raised to 1/3. So this is equal to a squared a raised to 1/3. And this one is equivalent to c raised to 15 over 4. So this is also equal to c cubed fourth root of c cubed. And when I convert this into exponential form, this is c raised to 3/4. So c raised to 15 over 4 is equal to c cubed c raised to 3/4. Is there a way wherein you can express this into this one into this, and this one into this without going through this process? Yes, there is. All you have to do is to ask how many of the denominators can you make out of your numerator. So how many 4s are there in 5? Just 1. So here it is. This is b raised to 1. Now, how do you determine what is left? So 1 times 4 is 4, and 5 minus 4 is 1. So here it is. 1 and then copy over 4. Let's try it here. How many 3s are there in 7? There are 2. So here it is, a squared. Now, how about what is left? So 2 times 3 is 6. And 7 minus 6 is 1. So here it is. Copy over 3. Let's try it here. How many 4s are there in 15? There are 3. So here it is, c cubed. Now, what is left? 3 times 4 is 12. 15 minus 12 is 3. Then copy over 4. We will be needing that skills later as we solve our examples. A radical is said to be in simplest form if it satisfies the following conditions. In my previous video lesson, I have already discussed the first one. So now, we are going to focus on the second one. The index cannot be further reduced. Examine these radicals. Which is simpler in form? The cube root of 3. Why is the second one simpler than the first? Because the index and the radicand are smaller in value. This is 12 and this is 3. This is 81 and this is 3. But the question is, do you think they are equal? We'll see. Reduction of index. Let's simplify the following. Number 1, 12th root of 81. First step, let us convert this to exponential form. So this is equal to 81 raised to 1 over 12. Remember that the index becomes the denominator of the exponent in the exponential form. Step 2, express the base as a power whose exponent and the denominator of the outer exponent are divisible by the same number. So I'll express 81 as 3 to the 4th power. 4 and 12 are divisible by same number, which is 4. Step 3, apply power of a power. So in power of a power, we are going to multiply the two exponents. So we have 4 times 1 is 4 and then copy divided by 12. So I have 3 raised to 4 over 12. Now I can reduce this into lowest term. They are both divisible by 4. 4 divided by 4 is 1. And 12 divided by 4 is 3. So I have 3 raised to 1/3. Last step, convert to radical form. So the denominator now will become the new index. So this is equal to the cube root of 3. So 12th root of 81 is equal to cube root of 3. We were able to answer the previous question if they are equal. Yes, they are. And notice how we reduced our index from 12 to 3. Let's have number 2, 6th root of 125. So again, first step, let's convert this to exponential form. So this is 125 raised to 1 over 6. And then let us express 125 as 5 cubed. Since 3 and 6 are both divisible by the same number, which is 3. Let us apply power of a power. So let us multiply the exponents. 3 times 1 is 3 and then copy divided by 6. So I have 5 raised to 3 over 6. Let us express this in lowest term. Both are divisible by 3. 3 divided by 3 is 1 and 6 divided by 3 is 2. So I have 5 raised to 1/2. And then let us convert this to radical form. So 2 will become the index. So this will be a square root of 5. So from 6, we were able to reduce our index to 2. Let's have another one. Number 3, 8th root of 64. Let's convert this into exponential form. So this is 64 raised to 1 over 8. And then I'll express 64 as 2 to the 6th power. 6 and 8 are both divisible by same number, which is 2. 6 divided by 2 is 3 and 8 divided by 2 is 4. So this will become 2 raised to 3 over 4. 4 will become by index, so this will become 4th root of 2 cubed. And 2 cubed is equal to 8, so our final answer is 4th root of 8. Let's have some more. This time, let's have variables. 8th root of b to the 6th, d to the 4th. So again, first step, let's convert this to exponential form. This will become quantity b to the 6th, d to the 4th, all raised to 1 over 8. Next, let us apply power of a power. So we're going to multiply the exponents outside and the exponents inside the parentheses. So this will become b raised to 6 over 8, d raised to 4 over 8. Next one, express all exponents in lowest terms, but make sure all exponents have the same denominator. So 6, 4, and 8 are all divisible by 2, so let us divide them by 2. 6 divided by 2 is 3, 8 divided by 2 is 4, so I have b raised to 3 over 4. 4 divided by 2 is 2, and 8 divided by 2 is 4, so I have d raised to 2 over 4. If you are going to tell me that I can still express this to lowest term as 1/2, 4 and 2 are not the same. Again, I have to make sure that all denominators of the exponents are the same. Why is that? Because that will be your new index. So now let us convert this to radical form. So 4 here will become my new index. So this is 4th root of b cubed d is squared. So notice that we were able to reduce our index from 8 to 4. Another one, 10th root of 16m to the 4th power. So now I have a combination of constant and variable. Again, let us convert this into exponential form. So this will be quantity 16m to the 4th raised to 1 over 10. And then I'll express 16 as 2 to the 4th power. Then I'll multiply the exponents outside with the exponents inside. So this will become 2 raised to 4 over 10, m raised to 4 over 10. I'll reduce this to lowest terms, but make sure denominators are the same. 4 and 10 are both divisible by 2. So 4 divided by 2 is 2 and 10 divided by 2 is 5. So this will become 2 raised to 2 over 5, m raised to 2 over 5. This 5 here will become my new index. So this is fifth root of 2 is squared, m is squared. And 2 squared is 4. So our final answer is fifth root of 4m squared. Let us continue. Number 6, fourth root of 25, p to the 20, q to the 8th power. So let us convert this into exponential form, but I'll express 25 as 5 squared right away. Now let us multiply the exponents. So this will be 5 raised to 2 over 4, p raised to 20 over 4, and q raised to 8 over 4. Now 20 divided by 4 is 5. 8 divided by 4 is 2. 5 and 2 are whole numbers. So only 2 over 4 will be expressed in lowest terms. And the lowest term of 2 over 4 is 1/2. So we have 5 raised to 1/2, p to the 5, and q squared. Now let us write first variables with whole exponents, and then let us convert this into radical form. So the index is 2, so this will be a square root of 5. Next, number 7, 8th root of 81, m to the 16, n to the 10th power. So let's convert this into exponential form. I'll express 81 as 9 squared. Now let us multiply the exponents. So we have 9 raised to 2 over 8, m raised to 16 over 8, n raised to 10 over 8. 16 divided by 8 is 2, so I could factor out m squared right away. Now 2, 10, and 8 are all divisible by 2. So let's divide them by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So I have 9 raised to 1/4. 10 divided by 2 is 5. 8 divided by 2 is 4. So I have n raised to 5 over 4. I still have one improper fraction here. So how many 4 are there in 5? Just 1. So we can factor out 1n. So we have 2 m's and 1 n. So that is m squared n. Let us copy 9 raised to 1/4. Now, what is left when we factor out 1n from n raised to 5 over 4? So the exponent of n is 1. So 1 times 4 is 4. And 5 minus 4 is 1. So we still have n raised to 1 over 4. So let's write first variables with whole number exponents. And then 4 here will become our index. So this is fourth root of 9n. Let's continue. Number 8, 15th root of quantity 2x plus y cubed. So what will happen here? Let's convert this to exponential form. So this is quantity 2x plus y raised to 3 over 15. And then let us express 3 over 15 into lowest term, and this is 1 over 5. So quantity 2x plus y raised to 1 over 5. Let us now convert this to radical form. 5 will become the index. So fifth root of 2x plus y. Next one, number 9, 8th root of 100 times the quantity p minus q raised to the 8th power. So let's convert this into exponential form. I'll express 100 as 10 squared. Now let us multiply the exponents. So this will be 10 raised to 2 over 8. Quantity P minus Q raised to 8 over 8. And 8 divided by 8 is 1. So I can factor out P minus Q. I'll write it first. And then fourth root of 10. Last one, the 8th root of 50, a to the 10, b to the 5th, c to the 12, divided by 2, a to the 4th, b, c squared. Let us simplify this first. 50 divided by 2 is 25. Since this is division, we will subtract the exponents. 10 minus 4 is 6, 5 minus 1 is 4, and 12 minus 2 is 10. Let us now convert this into exponential form. I'll express 25 as 5 squared. Let us now multiply the exponents. So this will be 5 raised to 2 over 8, a raised to 6 over 8, b raised to 4 over 8, and c raised to 10 over 8. Now, let us divide everything by 2. So 2 divided by 2 is 1 and 8 divided by 2 is 4. 6 divided by 2 is 3. 8 divided by 2 is 4. 4 divided by 2 is 2. 8 divided by 2 is 4. 10 divided by 2 is 5 and 8 divided by 2 is 4. So we have 5 raised to 1/4, a raised to 3/4, b raised to 2/4, and c raised to 5/4. Now, I have improper fraction here. So how many 4 are there in 5? Just 1. So let us factor out 1c. And then let's copy the rest. Then what is left with c raised to 5 over 4 when we factor out 1c? 1 times 4 is 4 and 5 minus 4 is 1. So we still have c raised to 1/4. Now let us write first c. And then let's convert this into radical form. The index is 4. So fourth root of 5, a cubed, b squared, c. Let us change the order of a radical in the nth order as indicated. Number 1, 8th root of 4 to a 4th order. So same process, we're going to convert this into exponential form. I'll express 4 as 2 squared. And then I'll multiply the exponents. 2 over 8 in lowest term is 1/4. Then I'll change this into radical form. So 4 will be my index. So fourth root of 2. So from 8 to 4th order. Let's have another one. 6th root of 27, b cubed, d cubed to a 2nd order. So once again, we're going to convert this into exponential form. I'll express 27 as 3 cubed. Then I'll multiply the exponents. And then I'll express 3 over 6 to its lowest term, which is 1/2. So this is 3 raised to 1/2, b raised to 1/2, d raised to 1/2. 2 now will become my new index. So this is a square root of 3bd. So from 6 to a 2nd order. Next is square root of 3xy to a 4th order. So from 2 to 4. So this is much easier. I'll just make the index 4 and then 4 divided by 2 here is 2. I'll raise everything inside the radical symbol to 2nd power. Then 3 squared is 9, x squared, y squared. So fourth root of 9x squared, y squared from 2nd to 4th order. Let's have another one. Cube root of 3bd to a 15th order. So I'll make the index 15 and then 15 divided by 3 is 5. So I'll raise 3bd to the 5th power. And then 3 to the 5th power is 243. So I have 15th root of 243, b to the 5th, d to the 5th. So from 3 to 15th order. Quick tips: the index may be reduced if the index of the radical and the exponents of all factors appearing in the radicand are all divisible by the same number. And remember to make the denominator of the exponents of remaining factors the same because this will be the new radicand. Now, it is time to check your understanding. Pause this video for more time. Let us answer number 1, 28th root of 32. I'll convert this into exponential form. I'll express 32 as 2 to the 5th power. 5 times 1 is 5 and 5 over 20 is 1/4. So I have 4th root of 2. Next one, I'll express 49 as 7 squared. So this is 7 raised to 2/4, c raised to 2/4. Lowest term of 2/4 is 1/2. So I have a square root of 7c. Next one, this will be p raised to 2 over 8 and q raised to 6 over 8. Then I'll divide everything by 2. So this will be 1/4 and this will be 3/4. So I have 4th root of pq cubed. Next, I'll convert this to exponential form and then I'll divide everything by 5. So 6 will be my index. So this will be 6th root of x cubed, y to the 4th, z to the 5th power. Last one, I'll express 81 as 9 squared. So I have 9 raised to 2 over 10, m raised to 20 over 10, and n raised to 6 over 10. 20 divided by 10 is 2, so I can factor out m squared right away. And then I'll divide 2, 6, and 10 by 2. 2 over 10 is 1/5, 6 over 10 is 3/5. So I have m squared, 9 raised to 1/5, and n raised to 3/5. So this will be my new index. So I have m squared, 5th root of 9, n cubed. Gets?